You can put it in the chat box if you want.
No.
All right. We're still going to try to do that dressing up for the week that we were going to do if school was in.
I can only see
I
your
think
head
they,
anyway.
huh?
I said, "Where's your body?"
My body.
Yeah,
Yeah, I
I
got
can.
some camo on.
I can't see it.
Yeah, well, I'm blending into the couch. I'm camouflaged.
Yep.
Um, I'm not sure what all the different days are, but if you want to participate, that is great. On our school Facebook page, there'll be a post that you can reply to with your picture. We're starting a new unit today, and still dealing with sales. So I'm going to present. I'm going to talk a little bit about some of the topics, and then I'm going to go into Canvas and make live our lessons or your assignments so you'll know what to do. So let me get into present mode, and you're just going to have to deal with my daughter talking in the background. She has a meeting at the same time. Let's see. I think I'm gonna do window. I'm gonna do here. All right. Oh, that's not what I wanted to do. Go away. Okay. I will keep it like this. Shh. Carolyn, you're too loud. All right. So if you look right here at this picture, um, you've got a picture of a fetus, and then you have a picture of a baby, and then young adult. So think about how this happens. Does anybody want to chime in and tell me how we go from a fetus to a baby to an adult? Does anybody want to chime
Age.
in? Huh?
Age.
Age. Well, what happens as you get older?
You mature.
I didn't hear what you said.
I said, you mature.
All right, you mature. What's going on with your cells?
Not sure.
Are you getting more cells, maybe?
Yeah.
Yes. So as we grow, we're adding on cells. So we need to know the process of how this is happening. And we know that the fetus begins with a fertilized egg. And that's when the egg and the sperm meet, they become fertilized and it becomes a zygote. And then something called cell division takes place. And so typically, cell division gives us rise to identical cells. But because of our DNA, we have something called differentiation that can take place. And as our cells are dividing in, once the egg and sperm fertilized, then things are going to start differentiating, and we're going to get our different tissues, our different organs, our different organisms until we have the one individual. So, hopefully, you're familiar with this breakdown of cell, tissue, organ system to organism. And we're going to have a whole separate lesson later on just cell differentiation. But to give you an idea, um, cell differentiation is pretty much irreversible. In other words, it can't change or go backwards. But we do have some special cells called stem cells, and they can differentiate into more than one type of specialized cell. And so, as an embryo, we have lots of those, and that's how we get all our different parts that develop our organs, our organ systems, and so forth. But even as an adult, there are certain places that we do have some stem cells. Bone marrow is one of them, and that's how we treat cancers like leukemia that are blood cancers. Um, You can find, oops, didn't mean to do that. You can find some connective tissue, your cartilage. These are things that your bone marrow can differentiate into. There's a few other places in our body you can find these stem cells, but that's the one that's the most known. So we can use these to help treat diseases like cancer. And embryonic stem cells, if you use those, it actually kills the embryo. So we'll have a whole discussion on this later, but that's cell differentiation. What we're going to concentrate on is the cell cycle. You're going to have two videos to look at, and I believe one of them, I'm getting all my classes confused. One of my classes, one is a little lengthier. I can't remember if it's this one or one of my other classes, but we need to be familiar with the cell
I don't
cycle
know when to I forgot when to make my prediction.
after she reads. Has she read the book yet?
No?
Okay. All right. So cells go through a cycle, and so the activity that you're going to do may start today and finish up tomorrow is on just the cell cycle, which involves a little more than just division. So the cell cycle is just a repeated pattern of growth in the cell and DNA being duplicated and cell division occurring. And this is going to occur, it's important, in eukaryotic cells. So that's cells with a nucleus. There's two main purposes. Cells need to be able to grow and then for repair. So think about if you get a cut, your body has got to repair that. And how they do that is by producing more cells. And as you are growing from an infant to an adult, your cells are dividing and adding more cells to you so that you are growing. So there's three main phases. You've got interphase, mitosis, and then cytokinesis. We spend a lot of time in mitosis. That's the actual cell division part, mitosis and cytokinesis. Interphase, you need to be familiar with it, that it is cell growth. And so we're going to look through each of these quickly. Interphase is divided, and this is what a typical cell would look like in interphase. You would have the nucleus. Notice that the DNA, you really can't see the chromosomes. It looks like a pile of spaghetti there. And you've got these two little barrel looking objects here that are centrioles. Interphase is divided into three stages. So you've got something called a gap or a growth phase. And this is just the cell is growing, it's making proteins, it's functioning like normal. And then at some point, it's going to replicate its DNA. So this pile of spaghetti is going to double itself. It's going to be a lot more, it's going to be a lot more there. Then it's going to enter a second growth phase or G2 phase. And this is where it just continues to grow, make proteins. It may make some more organelles because it's getting prepared for cell division. So, three spaces or three phases within interphase. And then let's look specifically at DNA. Um, DNA is long, stringy, continuous threads. We call it chromatin, but when it condenses in mitosis, it becomes what is called a chromosome. It becomes fat where we can actually see it. And we have, as humans, 46 chromosomes. So, so in normal body cells, you have 46 chromosomes, and they always occur in pairs. And here, we'll probably come back and do something with this. You need to know that this whole X is the chromosome, the center is the centromere. Each piece is a chromatid. They're identical because they're connected in the center. And at the ends, you guys don't have to really worry about this, is the telomeres. It's sort of the caps to the pieces of chromosome. So our DNA is in 46 pieces. Normally it looks like spaghetti, but in cellular division, When it's duplicated, and then when it shrinks down in mitosis, it looks like these X's here. So once interphase has completed, that's sort of a preparation, the cell's ready to divide. And so this is where we spend a lot of time, and this is mitosis. A lot of times we just shorten it and call it cell division, but it's really mitosis. It's a stage of the whole cell cycle. And the ultimate thing is that one cell will divide into two identical cells. We usually call them daughter cells. All right, so let's look at the different phases here. You need to be able to pick out the pictures. So prophase, you're going to see, I believe, two of those sets of barrel chroma centrioles, and they're moving to either side. You're going to see the nucleus um, still visible. Then you're going to have a point where the nucleus disappears and the chromosomes are kind of starting to move toward the center. So that's sort of an in between prophase and metaphase. Metaphase is always in the middle. Meta means middle. Chromosomes are lined up in the middle. Anaphase is where the chromosomes have been pulled apart. And telophase is when you will start seeing the nucleus reform, and then cytokinesis is when you see the actual two cells. And so we're going to look at these real quick in each of the phases. You're going to need to be familiar with what goes on in each phase. So prophase, you see the X's of the chromosomes. You may see the nuclear membrane, or it may start looking a little fuzzy because it's going to disappear. And you're going to see these spindle fibers, these long strings coming out of the centrioles, and you may see a second set of centrioles as well. So they're going to be on each, starting to be moving on each side. Metaphase, there is no longer a nuclear membrane, so the chromosomes are in the center. They're going to have lined up in the center. These spindle fibers will have attached here to each of the centromere of the chromosomes. Anaphase will then be pulled apart. So it's no longer a X, it's just like a little straight line. So they've separated the individual chromosomes. So these are now chromatids, and they move to each end. Then you've got telophase or telophase. You'll hear it pronounced both ways. You start seeing the nuclear membrane reappear around the chromosomes. Each side of the cell may start to pinch in a little bit, and the chromosomes will start to stretch out and look like thread like again. These little spindle fibers will start to break down, and the pinching in that you don't see here, it sort of dips in, would be the cytokinesis is beginning. And cytokinesis is actually the division. It's when the two cells divide in two. Animal cells form what we call a cleavage furrow. It pinches in two equal parts. Plant cells are different. Remember, they have a cell wall, and so they're going to build a cell wall in between the two nuclei, and that's called a cell plate. And so, why is it that cells divide, or how often? Well, cells going to divide at different rates depending on the need. So, here are some examples. So, your intestines, the cells in the lining of your intestines, can divide every 5 days. Skin cells could take every 2 weeks, unless you have a cut or something like that. Red blood cells divide every 4 months. Your liver cells divide once a year. That's why if your liver gets damaged, it's kind of bad. It's going to take a while for it to heal. Your nerve cells do not divide. That's why when you have nerve damage, a lot of times you lose the ability to use that part of your body that you've lost, you've damaged the nerves too, because they do not divide. Um, and cells are not dividing just so you grow and get bigger. They actually have to stay small. So they're not going to actually grow in size. They need to stay size. So you're going to increase the number of cells when you grow, not the actual individual cell size. That size needs to stay small so things can move in and out easily. All right. We're going to, I think, stop right there for today. I'm going to get Canvas up. You're going to have two videos to watch. And if that's all you get done today, that's fine. But I do have an activity that you have until tomorrow to get completed. So when you Well, I've got my thing split, so give me a minute so I can see all of it. Here we go. When you go into modules, and I'm going to make it live right now. I didn't activate the lessons yet because I wanted folks to be on here and I go through the lesson. We're now starting cell cycle, so I'm going to make that published so you can now refresh. I'm going to take all these others away. You can refresh and you should see the things under Monday. So for those that have been on the Google Meet, you don't have to worry about, you will not see, you'll see the Meet recording in case you want to go back. You will not see the Google Meet assignment. I will assign it to those who did not attend. Um, Here's the video on the cell cycle and cancer. This will get into a little bit of the regulation that I didn't get into today, and then just on cell cycle. So you've got two videos here. And if after you watch those, you may want to go ahead and start on this. Like I said, you can finish it up tomorrow.
I'm telling her about addiction.
Um, you're going to go to cells, click on this link right here, and you're going to actually fill in what different parts, what's going on at each of these cell cycles. So well, penalty. I was hoping I can't get mine to go over. But you'll see the cell cycle. Each one is numbered. So you can see on my screen 9, 8, 7, 6, 5, and I can't scroll mine over to get to the other side. So you can, for some reason, my computer does interesting things. Um, so when you go to this site, so I'm going to click on it. It should take you right here. And so when you play this or click here, so you could click on interface, it's telling you what's going on. All right, so that should be number one. You go to gap 0, it's this section. That's probably number 2. It tells you what to put here. So you can click on it or you can mash play and it's going to show you how quick, or it's going to stop at each thing and tell you what's going on. And then you're going to mash play. It's mainly telling you what's happening at these different stops. And so here's another checkpoint. And then here's the mitosis checkpoint. And then here it is. So you have to click on each one of these to get the information for each thing it's pointing to. So this is the diagram that's in the middle, and you'll have arrows that are pointing to different things. So for example, let me make mine bigger here. See if that helps. Okay. So number 6, notice it's pointing to G2. So at number 6, I'm going to type in what's happening at G2. Number 7 is pointing to that little space here. So what is happening at that space? It's usually a checkpoint. 8 is pointing to right here, what's happening here. Then 9 is that space. 10 is the rest of the M phase, what's happening there. and I can't scoot over. And then I think that's number one that starts interface. So the answers are right there in this. So for gap two, you would click here, and that's what you're going to put there. And to get the spaces, you have to look at the arrow, play the animation. So I hope that explains that. Are there any questions? Caroline, okay, why did you shut yours off, Caroline? Okay. All right, just all right, any questions? Now, some of you still have some work that you need to
No,
do
I'm good.
each unit. Does somebody have a question?
Nope.
Okay, I thought I heard somebody. All right. If you still have missing work, you need to work a little bit on that and to get caught up because we're not going to have time when we come back next Monday. For those that come on A day, we're not going to have time to make up work in class. So you're going to have to work on the missing stuff at home. Um, so make sure that you're working on that in addition to working on what's going on here because remember, you've got to have biology to graduate. So if you're getting if you're a close to graduating, you've got to pass this. You don't want to have to retake it. So remember, you can text me, you can email me, we can set up a separate Google Meet if you need some help, but you've got to contact me so that we can get that set up. Now, I know today, tomorrow, and Wednesday, time is going to be I'll have a little less of it because we're trying to do some parent conferencing. So, but I can fit you in as best I can. So just let me know if you need any help. So if there's no questions, I'm going to stop recording. I hope everybody's family is doing well and everybody's staying well. Remember, if you need anything, you need
Same
to
for you.
um, reach out to us because we can reach out to the nurse. We can, reach out to Miss Swearingen. We can, if you need anything, just let us know. All right, I'm going to stop recording